This is the Amp Hour Podcast, released January 5th, 2020. Episode 473. An interview with Greg Davill. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Greg Davill from Twitter.
Hey, Greg. How you doing?
Well, that's where everybody knows me from, so it's probably the easiest way to
there's a lot of
describe
people,
what I do.
Yeah, they know you from Twitter. Yeah, that's true. Happy New Year, I suppose. We're the first 2020 episode here.
Happy New Year. Happy holidays.
Yeah, same. Give us a little background. So if people aren't on Twitter, some people are on Twitter, but if some people aren't on Twitter, what is your background?
I'm just an electronics hobbyist. So just have fun electronics projects that I do in my spare time. Electronics engineer by trade. And so at my day job, sometimes I don't get to do all the fun stuff that I want to do. So when I come home, I just design boards, do surface mount assembly and take photos.
That's good. And so we've had you on the show once before, very briefly at KaiCon. So you traveled from Adelaide, where you live, up to KaiCon in Chicago. So that was great. And people can go listen to that. I think, I don't remember the episode, maybe like 430.2. It was the second episode of the KaiCon series. I know that. But people can go and listen to that if they are interested. And yeah, obviously you have a lot of great photography and boards that you work on. What is your most recent project?
Well, the most recent actual board that I've built is probably one that I've called the Arctic Koala, which is a board that breaks out the new Lattice Crosslink NX FPGA. So Lattice announced this FPGA on December 10th, and they had engineering samples available to purchase from DigiKey. So I managed to design up a board and have it ready December 18th,
nice.
I recall.
Yeah,
and I took that board to 36C3 Congress last year.
At the end of last year, yeah, right. Well, and we'll definitely get to that. I definitely want to hear about that as well. So this is a new part from Lattice. It's is different than the ICE40 family, or it's the same family?
No, so the ICE40 is their like ultra low power FPGA. Then they have their Crosslink series is more for media processing, like video streams and camera streams. It's very marketed towards the mobile phone kind of camera industry, it feels. And then they have the ECP5 line as well.
What delineates the two? What delineates between like a ECP5, which is like a higher end type of thing, and a video processing one? Does it have like different like front ends or something like that?
The video processing specifically has some more hard-coded I/O blocks for dealing with MIPI camera streams. So the MIPI standard has CSI and DSI, camera stream interface, and I think it's camera serial interface and display serial interface. And they're used a lot in mobile phones for cameras and displays. It's like a low pin count, high-speed serial interface. In terms of the actual FPGA fabric itself, the Crosslink NX series is pretty similar in performance to the ECP5 side of things compared to the ICE40, which is low power, lowish performance.
And so is this possible to use this with the open tools like LightX and MyGen and all of the Yosis and this synthesis tools?
Not at this stage, but the part was only released less than a month ago. So
okay.
It's a work in progress. I think Dave Shah's taking a look at the NX parts that he has, and I think from a surface level, it's very similar architecturally to the ECP5. So hopefully we'll see some movement on that this year.
I'm surprised actually that they would have like a mobile phone kind of like targeted one. Do you know the market segment are they actually going for mobile phones with FPGAs in them?
I'm not sure the exact market segment, but if you look at every new phone that comes out, they just seem to be incrementing the model number and adding a new camera to the back. So it seems like it's a reasonable market to go for because every phone now what differentiates last year's from this year's. Maybe there's another lens on there and it gives you some more fancy camera features.
Yeah, I
I
guess
don't
you
know.
could do that until you have custom silicon and you want to like take a lower cost thing to market, that kind of thing.
Yeah, and I think mobile phones, they're high volume products, but they're also a fairly short development cycle,
Yeah,
right? I mean, they
six
need a new
months.
phone every year to ring out.
Yeah.
Yeah.
So what does that look like then on boot? Like, so okay, so you have Archie Koala, you got it done in 8 days, which is, yeah, that's something.
There was a few board errata issues, but nothing I couldn't deal with.
Okay.
Just some rework for some.
What I mean, guess what else is on there too? Is this like a breakout, or what else is on the actual board?
Yeah, so I kept it simple. Are you familiar with the Icebreaker FPGA board from Peter Esden?
Yep. Yep.
Yep. So that was targeting the ICE 40, but it's got the programmer in all in one. So programmer memory, FPGA, just breaks out to some, they're called PMOD connectors. It's a standard from Digilent. So it's just 8 IO
Yep.
pins and power and ground.
Yeah, I feel like the standard is kind of it's a loose term on PMOD. It's like, it's a bundling of bundling of outputs.
Yeah, it's a standard connector format, not necessarily which pins do what, but that's ideal for FPGAs.
You need to have power and ground, right? I mean, I guess on the SuperCon badge, it was not. I think it was backwards, right? On the SuperCon badge, that's pretty much the only thing that needs to be right. So yeah, if you get that, you're good. You're golden.
Yeah. You can't reconfigure power and ground quite as easily as you can with IO pins.
No, 2020, man. That's the new thing,
So basically, I've taken the form factor of the Icebreaker board, and just that's a open source hardware board. So I've just taken the designs of that, cut the ICE 40 FPGA out, and dropped in the new Crosslink NX part.
Yeah, that's good because it's a familiar form factor, and people will be able to get up and running quickly with it. That kind of thing. Are you using the? Are you trying out the actual Lattice toolchain as well?
Yeah. That's right now the only way to program them with a toolchain they called Radiant.
What's it like?
I mean, it's like any vendor toolchain. It's a little bit more modern. I think this is a rework of what they had before, which was Diamond. So they're using both they kind of have two tool chains right now. Radiant targets all the ICE 40 parts and these new Crosslink parts, and Diamond is for the ECP5 range and some of their older legacy products.
Honestly, I wouldn't have ever used Lattice if it wasn't for the Yosis stuff, or the whole all the tool chains that are out there, Project Ice Storm and all that stuff. So yeah, it's good. It's good that I guess they get exposure from the open tool chain thing, and with the new Crosslink chip gets it too. That'll be good. What is the so have you've been able to play with the MIPI CSI DSI stuff?
A little bit. Unfortunately, I haven't had much spare time to play around with some of that stuff in the recent weeks.
Yeah.
But the board, the board's built now, and I've got a breakout board for a little iPod display that I'll be playing around with as time permits.
Well, so you had also shared recently on Twitter about the SuperCon badge hack that you did when you got back from the conference.
Yes.
You had taken a camera you had. Well, why don't you just tell us what it is?
So I had an idea to... So this all stems from your SAO that you made for, was it DEF CON 2016?
Yeah, 2017. Yeah.
So if anybody's unfamiliar, you made the Not a Camera, the NAC board. And it was a 555 project. Is that right?
Yeah. To be honest, initially it was supposed to be, it was going to say not a camera. And I was like, I was like very ambitious. And I was like, I'll put like a LoRa module on the back or something similarly. And then it turned into like, well, I ran out of time. And
yeah. So
as things go.
Yeah, you've got the 555 and then you sold them on Tindy as a bit of a getting started with soldering kit, right?
Yep. And I have videos too about how to go and do the layout as well, and my usual shtick.
No, it's really cool. So you plug it in, and the 555 blinks to a little red LED on the front, and the board is cut out and shaped like a security camera. but it says not a camera on the side, and there's a little red LED that's blinking.
Yeah, it was meant to be Marcel Duchamp. No, not Marcel. What was his name? Well, the guy who did um, th- "This is not a pipe." Ceci n'est pas un pipe. It's a piece of art that, anyways, it's silly.
Okay. Yeah, I wasn't aware of that. But so basically, I took your board designs, which are up on GitHub, and as soon as I found out the new Hackaday SuperCon badge was going to be FPGA driven, I knew that I'd have the hardware behind it to actually turn it into a real camera. So I took a little camera module I'd been using. You can set it up for 1-bit mode. So essentially, the camera outputs a data stream over a single bit. So you send it a clock, and it'll send back a data value, a frame sync, and a line sync pulse. And then the FPGA can interpret all these signals and reconstruct the image. And so this camera plugs into your normal SIO port on the SuperCon badge, which on the SuperCon badge actually has an extra 2 I/O pins, which were really helpful.
Right. Yep.
And then all of this feeds back into the FPGA and just displays the image, the camera stream on the LCD of the badge.
Yeah.
In glorious 320 by 320 pixels.
That's right. Yeah. The 1980s display, 1990s display. I think it's a really good example though of the flexibility, right? So you have these 2 pins, you're trying to do more with less in terms of, pin out, and you're able to push that data through those, that constrained interface. I think that's a very common use case for an FPGA, whereas people, usually have trouble kind of visualizing what an FPGA is used for.
Yeah, I mean, FPGAs excel in video processing and, camera stream, like any kind of parallel stream kind of interface they excel at.
Yeah, I was thinking data flow and streaming type stuff like that. Yeah. So internal on the FPGA then. So what does that look like? So you had to basically translate this 1-bit output. You said the FPGA was sending a clock out or a bit out, and then the camera was sending the serialized bit stream back.
Yeah. So in order to keep everything synchronous logic, I provide the clock to the camera, and it then basically it acts like a shift register back out to the FPGA. And I'm using some Verilog code that David Williams wrote. So he made a cartridge for his SuperCon badge that had a camera on it. And so he's already written some of the low-level LCD frame buffer kind of logic. And then I've replaced it with the front end for the camera interface I'm using.
So like when you send a clock to a little camera like that, so you're sending a clock out to it, it's shifting back just a bit stream. How do you tell it how big? Is it like the camera is limited in terms of how much it has anyways? It's like a 2 megapixel camera or something like that?
Yeah, so it's 320 by 320 pixels. So it's less than 2 megapixels. It's I don't know what that is. Is it 0.3, 0.6 megapixels or something?
Okay.
Quite a small image. But essentially, you just provided a clock, a free running clock. So there's always a clock signal at the camera. And then it has its own internal frame timing mechanisms. And so basically, it'll start spitting out data. And then between frames, there'll be like a blanking period, but it activates like the frame valid signal. And so it's like VSync and HSync, basically. There's like a line valid and a frame valid signal. And then there's also another interface to the camera, which is over I2C, which is how you set its configuration inside the camera. So it has a few modes. You can crop the image to 320 by 240, and you can adjust bit output timings, and you can switch it from 1-bit to 8-bit mode, which was what I was having trouble with at SuperCon. I couldn't quite get that step to work. Turns out you have to also have the clock divider set to 8 in order for it to enable that kind of 8-bit shift register internally as well. A lot of these camera's data sheet isn't particularly, how should I say,
Loquacious.
doesn't document the part very well. Basically, they expect you that if you have problems, you're a high enough volume customer to just be talking to a applications engineer directly.
The data sheet is transmitted verbally.
Yeah. Unfortunately, I don't have a sales rep or an applications engineer at this company to talk to.
Yeah. I was talking to a large distributor recently, and I brought up that exact same point that like I know that this is not a problem for all of them, and probably not even a problem for people that they really care about. Like large distributors care about large companies, and I get it, but I think that over time, large companies, like I think that there's more. It could be perception bias, right? Because I obviously am a solo person. You are the one person engineering department at the company you work at as well. So like I know a lot of people that do similar things, but I have to imagine that like big monolithic companies, there are fewer of them. There's a longer tail than there used to be, and having other resources for blokes like us, it's just like it seems like there would be more of a push for it, and so that's what I was pushing for.
Yeah, I don't know why. I mean, I do know why that they don't provide some of these, resources. I guess it feels like more of a support burden on their end.
Yeah, right. Everybody's trying to push down the bottom line, so it makes sense from that perspective. But still, it sucks for us.
Yeah.
But at the same time, you're not exactly using like I'm guessing this camera module was not particularly high end either, being 320 by 320.
No, I think it's targeted as a low power sensor for an edge device in machine learning applications. I think that's what it's actually targeted at.
Oh, okay. So like the one that's on that ESP32 processing board or whatever those ones that are out there, they're like all the ones coming out of China right now.
I think it might actually be the same camera sensor inside, but it's a different flex cable between them.
Well, still, it's very clever hack. I definitely liked it. So, what did it look like internally? Were you using like the MyGen tools and similar stuff internally?
No, so just pure Verilog. Like I mentioned, it was some code from David Williams that actually did the LCD driving. So he'd written basically an LCD driver directly. So you take out the SoC, the system on chip core that basically had the dual core RISC-V processor and the PIC inside that Sprite had written, and put in some pure Verilog that basically just takes the camera stream and then outputs it directly to the camera. So there's no CPU in the loop at all.
So it's just chucking frames on screen.
Yeah,
huh?
Basically just manipulating a pixel stream. Yeah, which unfortunately wouldn't have made a very good demo because it now means the HDMI doesn't do anything, because the HDMI was directly driven with the frame buffer interface from the SoC. So even if I'd got it working at SuperCon in this configuration, it wouldn't have looked very good as a demo on screen because, well, firstly, the camera's not very good in low light. And so in that dark hole during the closing ceremony, it wouldn't have really picked up much. And then I can't use the HDMI, so you'd have to be looking at the screen, which is also problematic.
Yeah, I mean, it's crazy like how much video is so normal these days. We see it in everything, and yet the amount of processing it takes and everything that's kind of behind it, at least I take for granted. But it's still pretty impressive stuff.
Yeah, there's a lot your phone camera does to process that image to make it look nice that you don't really think about.
Well, so you mentioned SuperCon. Obviously, we were hanging out at SuperCon. You were at KaiCon this year, and you also mentioned you were at Chaos Congress. That's a lot of travel coming from Adelaide, Australia. But how was Congress this year?
It was my first time actually, and I still don't really know how to describe it. It's a big gathering of German and European hackers, I guess. You went to Chaos Camp.
That's right. Yes, I was at Chaos Camp in Berlin in April, in August, and it's a lot of the same crowd, but it's a lot smaller actually. So Camp is I think 5,000 to maybe 5,000 to 7,000 people. I'm not sure what the exact numbers are, and then Congress is like what 30,000 people or something like that.
I think it's about 20.
Okay,
but still, I mean that's it's a lot of people.
Yeah, definitely. So how was the mix then? I mean, so you've been to many of the same conferences I have. Did you meet like a new crowd there, or was it actual hackers, software type people, or what?
Yeah, I mean, lots of the same crowd. I mostly fit around circles of hardware hacking, so there was plenty of crossover between all three events. Actually,
Hmm.
met a few new people that didn't want to make it to the US for SuperCon,
Right. Yep.
which is fair enough.
Okay. So, and what is the? I mean, did you do talks and stuff too, or was it mostly just kind of the social trading of tips and tricks?
Yeah, for me, it was just the social meeting people, talking about their projects, and seeing kind of what people are working on, I guess.
What is so? I mean, you are now our ad hoc correspondent here. So what'd you see? What'd you see that's different?
So, well, definitely everybody loves their addressable LEDs.
Yes.
So I brought my icosahedron, my
Hmm.
LED clad icosahedron, or you can call it a D20, 20-sided
Hmm.
polyhedra. Everybody seemed to love that, and there was three other people that had made LED cubes, and another guy that had made an LED geodesic polyhedra, so it's a much more spherical.
Uh huh.
That was really interesting.
Oh, that
Uh,
yeah. So that looks like yeah. I saw that one. It was like a lot of tiny panel, like tiny triangular panels, like a geodesic dome, like you're saying, right? What were the specs like? How many sides were that?
yeah, trying to run off memory here. I don't know if I can remember how many sides it was, but it
Hmm.
was each side only has 1 pixel behind it. So it
Oh.
lights up the whole area with one um, WS2812 kind of style LED
Hmm.
on the inside. And it's an entirely 3D printed frame, and it's about the size of a soccer ball.
So yeah, definitely good size, huh?
And then, of course, there was plenty of badge enthusiasts there, and seems like badges and add-ons are not going away anytime soon.
We haven't jumped the proverbial bad shark.
No, not yet.
Okay, well we'll get there. I'm sure we will. Let's talk about your how do you say it? Isocohedron?
Icosahedron.
Icosahedron. Okay.
Yeah.
Icosahedron. So what is it and how is it constructed?
So that was a project I created initially just to, after I'd created my LED cube, which is about Rubik's Cube sized, basically LED panels on every side. I thought, how can we make this more interesting? Cubes are nice, but there are other polyhedra. So the nice thing about the icosahedron is every side is triangular. So
Mm.
it's basically 20 triangles create this polyhedra. So it means you get by with less circuit board design, basically. It means I only have to design one triangular LED matrix panel, and then I could just make 20 of them,
Uh-huh.
and I'll have myself an icosahedron.
Nice. So this is a
So,
project born out of laziness, I'm hearing.
well, not quite.
I'm just
Yeah,
just
I
joking.
mean, optimizing the problem. There's other shapes you could make, but some of them would require pentagons and octagons and
Hmm.
different sizes. So basically, decided on the icosahedron. Had to work out how to model an icosahedron in Fusion 360,
Mm.
which is a bit of a non-trivial task. I ended up watching a YouTube video that walked through and basically followed exactly the steps that this guy took. And once I had a model, I worked out what size panels I'd need for an object about the size of a tennis ball was what I was going for.
Uh-huh.
And so what that ended up being is 20 circuit boards with 120 LEDs on each of them, and then some LED drivers on the back. And then the drivers are constructed in a shift register format. And so the 20 panels are essentially daisy chained together. And then there's a controller on the inside that has a little FPGA on it, because I'm reusing work from Peter Esden and other people that have made LED cubes. The code is already written for that FPGA, so I could just take that and reuse it on my project. I don't have to make my own code to drive the LEDs.
Yeah.
And using that, I created a little custom circuit board that fit on the inside, and the whole thing fit into a 3D printed enclosure.
So how big is this shift register? So is it just single shift register, or it must be multiples?
So every panel essentially architecturally looks like an array of 16 by 16 LEDs,
Okay.
except that only half of them are populated. You can imagine a square of 16 by 16. If you cut that diagonally, I basically threw out the top half of that triangle, and the bottom half is what is populated on the circuit board.
Oh, okay.
But the LEDs are multiplexed with shift registers that we've got 16 bits multiplied by 3 because they're RGB LEDs. And then we have a 16-bit kind of row driver. So with these shift registers, they are all cascaded in basically in a single chain. So we have 3 sync drivers, 16-bit sync drivers that drive red, green, and blue channels. And then there's another set of 2 74 series 595 shift registers that drive the anodes of the LEDs. And basically, that just looks like a single 64-bit shift register with clock, data, latch, and blank signals.
And so how fast can you clock something like that then?
The shift registers probably let you run up to I want to say 30 or 40 megahertz before they'll give up, basically. And with the number of LEDs I've got, I broke the chain into 4 sets of shift registers, and they're kind of 5 panels long. And with that kind of breakup, I can drive all the LEDs in a 10-bit color mode at about 120 frames a second.
Whoa. Okay. Nice. So then what does it look like? So you have 10 bits of color, you have 120 frames per second. What does it look like when you then map this? So you're like, okay, I've hooked all this stuff up. I got it in the FPGA. It's all mapped out, which is non-trivial, of course. But what does that look like for like writing software to drive the actual programming of these LEDs?
So I'm still a little bit lazy on this aspect of the project. Basically, the FPGA has a frame buffer inside that is just a 2-dimensional frame buffer. So remember before I said that every panel essentially looks like a 16 by 16 array of pixels, but we're cutting that array in half diagonally. It turns out, well, the way it's working internally, it's still driving the other half of that, the other half of those LEDs. They're just not populated anywhere. And so the frame buffer is just a 2-dimensional frame buffer. And then in order to actually display on a single panel, you need to remap how that frame buffer is turned into a checkerboard and then diagonally sliced, which I haven't done. All of the animations I've built for this so far have just written to the 2D frame buffer directly.
Well, it still looks good, so who cares, right? I mean, like, you're getting to the core pieces here, so like, yeah, that's what you really care about.
Yeah, the animations I've written, I kind of picked so they don't highlight this fact. But say I wanted to make so there's an accelerometer inside, and so it could actually always have a dot that appears on the top surface as you move the icosahedron around. In order to facilitate an animation like that, I would need to do basically what you're describing, to do like a remap between this 2-dimensional frame buffer and basically, I think you'd want to do almost spherical coordinates around the icosahedron.
Like an arm theta or something like that.
Yeah. And that would just be a one-time calculation that would be encoded into a lookup table.
Okay, well, more to do, but it's not. It's beside the point, really. I mean, I was just curious about the mapping in general because I think about LED projects, and that's usually where I get held up. As I'm like, oh well, how do you how do you actually write software for it that looks interesting and you know um, just does something. Like I feel like I can,
Yeah.
I could design the boards, I can design the, and maybe figure out the FPGA piece, but then it's like, oh, okay, well, I got to call a software person or something like that, and so that's where I was kind of curious about that piece.
Yeah. In fact, I've seen since I built this, there's been two other projects that have appeared on my Twitter feed actually. One from horrible with names. Jury, I think is his name. He makes some brass sculptures, and he's made
Huh.
an entire sphere out of WS-2812s.
Oh, yeah, I saw that one. Yeah, that it was like rolling in the dark, right?
Yeah,
Yeah.
yeah, and actually, just this week, somebody's made one using circuit boards that are fitted in kind of like an arc shape,
Yeah, like a slice of
and
an
so
orange that are kind of like
yeah,
crossover for one another.
yeah, and the most recent animation they've made is from the side, making it look like a Pac-Man,
Oh, yeah.
which I
Yeah,
thought
yeah.
was pretty creative.
Yeah, that's great. It's nice that like this kind of stuff, it's you're not making a product here, right? It's not like you're selling a D20 die to gaming nerds. Although that would definitely kill at game conventions. I'm just saying. Uh, but
Uh,
you know,
yeah, it would definitely probably kill my wrists as well, placing that many
yeah,
LEDs.
I think
Although
maybe
I
you
feel
could
like if
outsource
I
it at
made
some
another
point.
one,
Yeah.
yeah, yeah.
How long did it take to assemble those?
Well, I did it all piecewise. So I did like the LED panels were panelized as a four circuit boards in one. So I just had to assemble four at a time,
Uh huh.
and each four probably took maybe an hour
Oh,
of placing
okay.
LEDs. So it's not too long.
So 15 minutes
But
per, but
that's
times 20, and then the actual mechanical assembly and the coding and yeah, the
yeah, and
plugging.
we'll ignore the fact I had to rework all the boards. But
Right, right. Yeah, all the normal things. And then so you 3D printed the actual the chassis that was holding this, or how did that work?
no, so I designed it to be 3D printed, and then had Shapeways make it out of nylon.
Oh, okay. Yeah, yeah.
There's quite a lot of fine detail, and I tried doing test prints on my FDM printer. I've got a Prusa i3,
Uh huh.
and it just didn't turn out. I mean, there's we're talking about you need a little pocket on every side
Yeah. Yep.
that's just over 1 millimeter deep
Yep. Yep.
to fit
Yeah, because
these
it's press
circuit
fit too,
boards
right?
in.
That's the other secret of this thing.
Well, it's supposed to be press fit.
Yeah.
When I
Dab of
rebuilt
glue.
it, yeah, I used some silicon,
Yeah.
some
Like some RTV or something.
yeah, some RTV silicon just in every corner. So it's still replaceable if I need to, but
Hmm.
that just holds every panel in and actually gives it a bit of shock absorbance.
Oh, yeah, that's good. So not quite ready for production yet. That's what we're really getting at here.
Yeah, yeah. In fact, I've still got to tidy up some of the files and release them onto GitHub so
Yeah.
people can make their own if they're well inclined.
Yeah, I saw you tweet about that to someone. Did you say like BOM cost was about like less than 100?
Ooh, no.
Oh no. Okay.
The LEDs were less than $100. I think it's about $60 worth of LEDs, like just the
Wow.
LEDs.
Okay.
And then the driver electronics are probably also about another 60. And then circuit boards are basically free at this point.
Yeah. Right.
What a time to be alive.
Yeah.
But then the 3D print was, I paid to have it rush made because I kind of ran out of time with this project.
Right.
But Shapeways charged me about $150 for that.
Woo. Yeah.
Just for the 3D print. It's about tennis ball sized, but I mean, they're made on a $500,000, multi-million-dollar machine. So
Yeah.
I guess it makes sense they can charge that much.
I have a where KaiCon was. I don't know if you took the tour when you're at MHub, but there's a printer there where they just charge for material. It's probably the best deal. It's probably worth the cost of the membership just for that because it's like it would have been like $20 compared to 150. I've like done shapeways comparisons before, and it's like material cost alone is pretty killer.
Should have called in a favor and had you make it.
Yeah, next time, man, let me know. It's only they only run it once a week, so that is the downside. The rush thing does make it more expensive, and then shipping to Australia.
Yeah. Yeah. I think I did take a look at that when I did the tour.
Yeah.
They also had the little colored donut there.
Oh man,
right?
that thing. Yeah.
It's a lot more dense than I would have thought.
Yeah.
Because
Yeah.
that's like a powdered nylon. Was that powdered nylon?
No, that one is that's
Powdered
the
something?
Objet. So they get bought by whoever they got bought the other big one. But it's like I guess maybe it is nylon. I don't know what the powder is made out of, but it's like an inkjet process, and it's a little bit different because it's like a color based ink instead of just the binder by itself.
Okay. Yeah.
It's it's fun for a demo. I wonder about the 3D printing. Like when would it be useful to have like a colored demo like that? Like if I was an industrial designer, maybe, if any of my 3D models had any element of design to them.
I leave a lot of the design stuff to the designers.
Yeah.
Just focus on the electronics.
Exactly.
Yeah.
They're great at it. They'll get that stuff done. So you mentioned the the rush shipping and getting it to Adelaide and stuff like that. What is Adelaide like? I mean, what is your part of the world like?
It's right now it's quite hot. Although we just had a cool change come through. So last week we had 40 degrees, or 2 days ago was 40 degrees.
Yeah.
And today we had rain showers. So
that's good.
I really don't know what's happening with the weather.
Yeah. Well, yeah, I mean,
and we still
obviously
have
lots of Australia is having lots of climate issues right now. I don't know if the fires are near you, but
no. Well, so a lot of the fires are on the East Coast right now.
Yeah.
Unfortunately, we had a fire break out on a place called Kangaroo Island, which is just an island you can get a ferry off to. It's a nice little tourist destination.
Mm-hmm.
But the fires there, I think it may have got through like 1/3 of the island, which is pretty devastating.
Ooh, yikes! Yeah, it's tough. You're further south. I mean, Adelaide's the bottom of Australia, right?
Yeah, kind of central at the bottom.
Yeah. Is there an electronic scene? I mean, what does that look like? I mean, obviously you have a gig there, but what is the professional scene like there?
Tough.
Yeah. Okay.
A lot of my friends that graduated the same year as me, they've moved interstate. We have a little bit of a resurgence now we've got a few like space initiatives starting up with our new government-backed space agency that's now headquartered in Adelaide.
Oh, that's cool.
The government's trying to push grants out to local manufacturing and electronics industries, so hopefully we'll see a bit of a rise there.
But no, I guess what I'm really getting at is like, are there enough people to have like a 5-person meetup? Like, is that kind of a tough ask?
It's a little bit tough. We do have a hackerspace here.
Okay, that's a good start.
The facilities are a little bit varied compared to international hackerspaces, though.
Well,
we basically share space with the university 1 day a week, and then there's another meetup on the weekends that's at a community center space.
Yeah.
So there's no real 24-hour access to like a facility that you can go to and hack around on things yet. Well, we do have a makerspace that's opened up in the city. That's only a recent addition though, so hopefully we'll see that extend this year.
Well, what I'm hearing here is if there are any listeners in or nearby Adelaide, give Greg a call. That sounds like you never know. Like it's always weird too. Like I keep meeting people that are like in Chicago. I mean, obviously Chicago's pretty big, but like just you never know where the maybe the introverts are hanging out in their garages or their lofts or wherever they are, and it's good to get the word out where you are. So
yeah, I mean that's obviously true. I mean I tend to just stick to my home lab here just because it's a bit more equipped than the hackerspaces meeting areas are.
Oh, totally. Yeah, I mean, I go to hackerspaces for social events. I don't go for gear. I have my own stuff, and sometimes I'm not willing to share it. Not to sound bad about it, but you never know. What's going to happen to it. Well, let's talk more about projects that you've been working on. I mean, so you did that one. I think you and I first interacted. I think on Twitter about that tracker that Sam R34. It was like a LoRa tracker. Is that right?
Oh, yep,
Yeah.
yep.
What ended up happening with that?
It's sitting on my desk right now. In
Okay.
fact, I can see it.
It knows exactly where it is. So do you.
It's
So it sounds like it's a hell of a tracker.
yeah. I mean, I know where it is, and it knows where it is.
Yep.
No, like a lot of projects, that the hardware is what I really excel at. So I designed up the circuit boards, had them manufactured, got the bare circuit boards back from China and assembled them. Took some nice fancy photos and threw them up on my Twitter feed. And now it's sat basically idle because I'm too lazy to write the firmware for it.
Well, I mean, that's work, right? I mean, that's what you do for work. So
it's a fate that a lot of my projects fall into. Yeah, I mean, at work, I do the same thing. Basically, it's I do the full stack, so I have to do the hardware, software, and firmware side, and then also documentation. So
yeah,
basically, I stretch that muscle enough at work that sometimes I don't want to write firmware for my hobby projects.
yeah. No, I feel it, man. That's my goal for 2020 is to do more of the firmware projects at home because I need to improve my skills. But yeah, it sounds like even just saying it like that sounded like it's me going, it's me going to the gym. I'll give up on it in March or something. Well, that's cool though. So what was that project for people who don't know?
So basically, I created a little GPS tracker unit, maybe 4 years ago now, for a local beagle club.
What is it?
They
what is
wanted
that?
to be able.
Sorry.
I'd say beagles, the dog.
Yeah, I got that.
Beagle dogs.
Yeah.
So
wait, it's a club for people that are like beagle enthusiasts?
No, beagle owners. So basically, beagles are really good at tracking scents. And so there's all these clubs around that let you take your beagles, and it's they run a trail bike with some raw meat dangling from the back around like farmland, and then they let the beagles chase the scent.
Okay, so it's like
they basically work up to this, but they chase the scent. It's at the pack hound level, which is the higher level. I think it's about a 5 or a 6K kilometer track that they run.
Wow.
Following this scent. And they follow it pretty closely. Basically, they wanted a GPS to just put in the pouch behind the dogs so they could look at how closely they were following, and they could put one on every dog and see, oh, hey, this dog, walked around the tree 5 times before getting back onto the scent. That's why he came back late,
Right.
And so I made this little handheld device, battery powered. I think this one was MSP 430 driven because that's what I was using at the time. Just takes a GPS feed, records it to an SD card inside, and then you can download the logs later over USB. And this project worked pretty well. And so I had all these enclosures left over after I'd done a small batch for this club. And so I decided to redesign the board with a wireless interface. So you could potentially have a LoRa receiver and have it transmit just packets over LoRa. I wasn't really focusing on the LoRa WAN aspect of kind of that ecosystem. Just the LoRa transceiver itself, long range, or low power, long range, kind of, and also low bandwidth. I mean, I was just wanting to send basically just
ID number,
GPS
and then
coordinate
where they
packet.
are at the time or whatever.
Yeah, and so basically, Atmel had just come out with this new part, which I think you were using, or you mentioned it on the amp hour. So I thought I'd pick some up and design up a board for it. And so I've built the boards, but I haven't programmed them yet.
These things happen.
But that's kind of where the project grew out from. So I mean, this was really just a hobby thing to maybe play around with this chip.
I think that the first thing I saw, I think it was the first time I saw like the renders you were doing too, and maybe we could talk about the renders real quick because you gave a talk at KaiCon about it, but that's part of like the people looking at your Twitter feed, regularly see these renders that you're doing. So, and that was one of the first ones that I saw, I think, as well. So, what is your process there? Like, what are you doing with the rendering?
Yeah, basically from KiCad, you can be stuck in the design page of KiCad looking at your circuit board for so long that you kind of can't see the trees from the forest. And I always find that if I switch into the 3D mode and I'm looking at the 3D board, suddenly I get so much more insight as to like, oh no, that button is way too close to the connector there. I'm not going to be able to push that. Um, and then also there's an aspect of mechanical integration to get a circuit board to fit into a mechanical assembly, like an enclosure or a case. So there's a need to have a 3D representation of your board. And so KiCad actually has an option now for exporting step models, so STEP step. And those can be imported into mechanical environments. Fusion 360. There's actually another file format KiCad exports that you can import into Blender. And so I was doing this just for the mechanical aspect. And then I realized that these CAD programs have a way to render boards. And so I started playing around with that and just, taking a look at what board renders look like. And then from that, how different is a physical board to what the program renders. And straight away, you'll see that KiCad doesn't export the actual copper layers or the silkscreen or any of like the actual features on a circuit board. It just gives you like a blank solid mass.
Right. Yeah, it's basically
And so the
a
first
rectangle,
step,
a 3D rectangle, cube, I guess.
yeah, more or less just a little flat solid. And so the first step was poking around at plotting settings in KiCad. You can plot PDF files of your boards, PDF, and then I moved to SVG. And so you can plot the copper layers as an SVG file and then convert that to a PNG and then apply that as like a texture almost to that solid circuit board in the mechanical CAD tools. And when you render that, it looks worlds better.
Yeah, it's almost like a wallpaper that you're wrapping around a piece of like solid material kind of thing. Like it kind of warps around it, that kind of idea.
Yeah, more or less. And then instead of doing all this manually, I started poking around at the scripting features in KiCad. And so I've written a few Python scripts that integrate into the scripting environment in KiCad. And so just by running the script, you generate a stack of SVG layers. It's colorized and then exports to a PNG file. And then this basically, is like what you're saying, a wallpaper, or I think Fusion 360 calls it a decal, like a sticker that you basically are putting
right.
onto your model. And then that basically gets you like 80 to 90% of the way to like almost like a photorealistic board. You're missing a lot of the material properties of a real circuit board.
Right. Yeah, like the reflectiveness or whatever, reflectivity and like what absorbs or bounces light, that kind of thing.
Yeah, and the fact that a lot of these things you kind of almost take for granted. I mean, you look at a circuit board and it just looks like a circuit board to you. But if you get light to bounce off of the right way, you can have, say, the ENIG might show up, like the gold-plated pads, but the surface of the actual solder mask is reflecting all the light if you get the angle just right, and it might just appear white because it's reflecting light. And so it's hard to get all of these materials to map perfectly. So I basically stopped trying to achieve any closer to photorealism and just kind of stopped to that 80% mark.
Yeah.
But even with that, you can enable features in these CAD tools like depth of field.
Right. Yeah. Right. And that really makes it feel like real, right?
Yeah. Suddenly it makes it look like you're using a real camera. It's not like, you get the depth of field that you would get if you were using a macro lens.
Yep.
You're right zoomed into your board. And so I've started just turning those features, basically turn those on because they're in the programs and gives you a bit of an extra depth, you can say, for free.
Yeah, I mean, it's kind of just tricking the human eyeball into thinking it's looking at something real. Like that's kind of what it comes down to. Obviously, there's like eye candy that's on Twitter. Do you find? I mean, you've mentioned kind of the 3D kind of piecing stuff together. Is it because the geometries are so small, or because you're using weird case sizes, or how do you find it's most useful?
Moving back to the icosahedron project, I exported the boards from that and had them in my mechanical 3D environment just to look at things like how the PCBs will be mounted. So the LEDs have a certain height. I think the LEDs I'm using are maybe 0.8 millimeters thick, and then the circuit board was going to be 1 millimeter thick or 1.2. And I couldn't quite decide if I wanted to go 1 or 1.2, and so exported it into the 3D model, and you can basically embed the circuit board into the shape I'd already sent off to be 3D printed. And I could basically tell, hey, I do want this a little bit thicker so the LEDs are sitting flush, or they're going to sit poking out a little bit. And it's just kind of the entire mechanical integration aspect. I mean, some projects will just stay as a bare circuit board forever, but most products don't exist in that form. They're going to be in some kind of enclosure or some kind of case. And as soon as you have, buttons on your circuit board that have to be exposed through a opening, an enclosure, or, like a button in an enclosure that has to actuate on a button on the PCB, kind of all of these problems helped with the 3D representation.
Yeah, that's good. That's good. One thing I wanted to talk about that we haven't brought up yet is soldering stuff, mostly because that's another large part of your Twitter feed is showing these these solder hacks or I guess reworks and similar kind of things. And I was wondering if you had. I mean, so another one of my goals for 2020 is to just get better at soldering in general. Like I have a pretty sloppy technique. I don't know if you have any like tips and tricks to just kind of how you find yourself improving or what you find on a daily basis to make you better at soldering.
Yeah, I'm not sure. I mean, I guess I've just gotten better with time and practice, and I guess I'd say try to practice soldering with low risk projects. So you really shouldn't be, looking at a board that you have to get working tomorrow and it's 2 a.m. and, you're bumping your head.
Right.
It's like, I just need to solder this one bodge wire will fix, everything. But the bodge wire is, under a BGA part that you've got to route out. So that's a very, I guess, like high risk environment, and you're pretty likely to mess it up if you haven't done that kind of stuff before. And I mean, a lot of the times with practicing this stuff, I'll mess it up, but it doesn't matter. Like you could just try again. I'm not really reliant on a lot of my soldering hacks to go into kind of production things.
Yeah.
I'm just trying to get boards that I've made working without having to kind of respin them.
Yeah.
On kind of like a hobby
saving
level.
time for spins and similar kind of things.
So I don't know if I have any tips.
Well, I guess what's your setup at home? Like maybe that's a better question probably.
Okay, I mean a lot of people might laugh at this. My soldering station is a Quicko brand.
Is that like the cheapo low cost hot air pencil?
Yeah, so this is just a soldering pencil. It takes T12 tips, which is a Hacko style tip. But Quicko is a brand I found on AliExpress for about $30.
Nice.
So that's the soldering iron I use at home. A $30 soldering iron. Works great so all the soldering I do is lead free. Mm-hmm. So works great for the lead free stuff.
What's your solder and flux of choice?
I quite like the SparkFun lead free solder.
Okay.
Which is what I've been using. I bought a 500 gram spool of it. Geez, I don't know, 5 years ago now. I've still got 200 grams left.
Nice, yeah. It doesn't go fast. I mean, even with lots of projects, you can really get away with having around for a while.
Yeah, and soldering paste, I've bought quite a large quantity now of it's a Loctite GC10. Uh-huh. Unfortunately, you have to buy a large quantity. You can only buy tubes of 500 grams or 600 grams, which ends up to be quite cheap per gram, but it's still, you have to buy 500 grams worth. So it's not really a cheap investment, unfortunately.
Yeah.
But it's turned out to be really good solder paste, and that's what I use for everything now.
And what about flux?
Flux, I don't quite know the model number off the top of my head, but it's a tacky flux from Amtech that I found out about from watching some of Lewis Rossman's MacBook repair
Oh
videos on
yeah, yeah.
YouTube.
Past guest of the show,
So
Louis
that's the
Rossman
flux he
is
recommends.
probably That I mean, watching that guy solder is it's impressive. He's doing some small stuff.
Yeah, and I think he's probably started in a similar seat. I mean, none of us, are born knowing how to solder BGA components.
Yeah.
We just kind of learn it.
Yep.
And I think he just like self-taught himself all of that, right?
Yep. What about? I mean, I guess another thing is magnification. I mean, Lewis obviously, and you as well. I mean, like I think that's a big thing that I've come around to is like it's not cheating to have magnification. That's necessary. It's smart. It's like I don't know why I avoided it for so long, but like I always used to try and hand solder stuff with just like my eyeballs, and then I'd finally looked at my solder joints under a microscope, and I was like, oh my god, what am I doing here?
Yeah. So I mean, I bought last year. I bought an Amtech. Hang on, no, Amscope.
Amscope.
I don't know why every company has to start with Am. Amscope is it's the American brand of like a Chinese series of microscopes or something. But they're quite low cost, affordable microscopes. So I bought one of those from, I think, just from China.
Yeah.
And so stereo microscope, so 2 eyepieces, that gives you the depth perception under the microscope.
Yeah, so it's like you're actually using your eyeballs
just,
instead of looking through eyepieces and that kind of thing.
Yeah, and I think with the setup I've got now, it's about a 3.5 to about 20 times magnification.
Yep.
So 3.5 is good. Like that's the widest you can go.
Mm-hmm.
And that gives you a view about like of a credit card sized working area underneath. And then you can definitely zoom all the way in if you need to inspect joints or if you're soldering bodge wires on.
Yep.
After getting that at work, I found one secondhand, basically the identical microscope, but it's a Japanese branded one. And so it's a little bit more expensive, but the optics are just a little bit, it's hard to really put your finger on it. They're just like sharper.
Oh, okay.
Basically, almost functions the same. I could switch between the two. The Japanese one, the camera, so that it's a Japanese one's a trinocular port. So it has a port for your camera to attach to as well. And you can use the camera while using the eyepieces.
Yeah, that's nice. That's
which
really
is
nice
a feature. A lot of them.
Yeah, seeing what you're doing.
Yeah, a lot of them call that simul focus, I think.
Oh,
to be able to use both the camera port and the eyepieces. Some of the cheaper models, they give you a little switch that you basically push, and that moves a mirror in and out, and basically the camera basically just redirects one of the eyepieces. And that's, if you can avoid that type when you're buying them, I definitely would be looking for the one where all 3 ports are active at the same time.
That's good. Well, nice. That's nice.
So do you have a stereo microscope now?
I have one at M-Hub has a couple. They're not stereo though. Yeah, they're just mono. It's like dual eyepiece, but mono. I think it's the same view because I don't get much depth out of it. And but yeah, stereo is nice for that for getting additional depth and stuff like that.
Yeah, the other type is I guess what Dave has, which is like the Mantis scope,
right?
Which I think is like a heads-up LCD almost that you look into.
Yep.
But they're almost a different price range.
Yeah, definitely. Yeah, you need to have enough like focal range so that you need to have enough zoom, I guess, to be able to get in. So you have your hands are free under there. That's kind of like one of the big things. I feel like the lower cost, older microscopes, it's like, yeah, you can get in as close as you need to with like how it looks, but you're also going to be right on top of your scope's right on top of your solder iron, which is not what you want to have.
Yeah. So with the stereo ones, you get something called a a Barlow lens, which basically attaches to the bottom of the microscope, and it will halve the zoom distance but double the working distance. So that's what I have on mine, which gives me about 15 to 20 centimeters of working distance, which is, plenty to get light into your seat, in and around what you're working on, and, soldering iron and your third hand,
Yeah, and to get it up off the table if you needed to. I mean, like, it's nice if you have like one of those low slung holders. What do they call those? Like I think you have one of those, right? The clamps that are like directly on the desk.
Yeah, mine clamps on the side of my desk, and it has like a swinging arm.
Oh, okay.
The scope can swing out over the desk.
That's great. So, okay, one last question about soldering is your solder paste application, because that's another thing that I notice in your photos all the time. Is you have these super clean solder paste pulls, and I know that it's social media, so it's a selection of the best ones, I'm sure. But what does your solder paste technique look like? I mean, are you using stencils? Are you using frame stencils? Are you using loose stencils? Are you do you have a jig? How are you doing all of this stuff?
Yeah, actually, a lot of the time you can tell if I've had to wipe off the solder paste, can try again, because you get little solder balls stuck under the solder mask.
Oh, yeah.
But often I can now get pretty good application on the first try if I spend time setting it up. So for a lot of my hobby boards, I will use just unframed stencils. So just basically the stainless steel sheets that you get from fab houses, just a standard laser cut stencil.
Yeah, I will say those are, I have recently determined those are the most dangerous pieces of equipment that are in my entire lab. Not hot soldering irons, not, cutters, not X-Acto knives, nothing like that. I sliced the crap out of my hand by not realizing there was a solder paste or a stainless steel sheet underneath something else, and I just like jammed my hand into it. Oh my god, I was bleeding everywhere. So be careful about stainless steel, folks. That'll cut you deep.
Yeah, yeah. I mean, they're pretty sharp on those corners.
No, not even the corner. It was just an edge. It was just an edge that, like,
but just the side.
Yeah, I just pushed, flesh into edge of stainless is like it's a knife. It's a dull knife.
Yeah, especially you can get like thinner ones. I think some of the thin ones I've got are probably 1/8 thou thick.
Oh, really? Okay.
Which is, so you're basically on the verge of like razor blade thickness at that point.
Yep.
Yeah, so I just use unframed stencils, and you do be careful of where you store them.
Now you tell me.
Well, if you buy them from Osh Stencils, they have lots of warning tape that says, stencil is sharp, do not cut yourself. But the ones from China just come in a Ziploc bag. Yep. So I use circuit boards around the board that I'm actually trying to stencil, just to raise up the stencil off the table and have basically a flat plane that the steel sheet will sit on. Because if you don't do that, basically if you were to bend the edge of the stencil down to the level of the table, it would bow the entire stencil. It wouldn't be sitting flat anymore. If you can kind of imagine that.
Yeah. It's like it's like if you're stretching saran wrap over a book or something like that. You get like that bend down kind of thing, or tinfoil or something.
So I think it's a common technique to use spare PCBs, because then they're all the same thickness. It gives you a nice level field. And then I use blue painter's tape. I mean, you could use just masking tape to hold down the stencil. So you kind of align it by eye. I use blue painter's tape along one edge. And I always use fresh solder paste. So that's another key thing.
Yep.
I like to store my paste in a syringe, like a Luolock syringe. So like a blunt tip. And I'll apply solder paste to the stencil, just like a long bead along the top. And I've recently bought a proper stenciling squeegee.
Oh, yeah.
So it's got a stainless steel blade in that gives you a lot more force to apply like as you're squeegeeing. And then, often I used to think that you had to squeegee in one single stroke in order to get a good application. A lot of the time now I try to do like I just try to mix up my technique and be like, well, will this actually work? Will it make it worse or better? And so recently I've been doing like one squeegee down from the top and then up from the bottom. So like kind of in both directions. And that seems to be working quite well. And then I do one final pass, which is quite a sharp
Yeah.
angle.
To try and like scrape off the top and that kind of thing.
Yeah, I usually squeegee at a shallow angle to kind of push the solder paste through the stencil. And then I'll do a cleanup pass at a really sharp angle, almost like 90 degrees to the stencil, just kind of push down and across. And that just cleans up the top and really gives you a nice
photographical,
nice application.
Really nice looking solder paste porn photos.
Yeah, and then then I pull out the macro lens and set up the camera flashes and
softbox and
take some photos. Yeah, but one thing I found with this solder paste, it's got a great working life. I think on the data sheet they specify 24 hours.
Oh wow!
From when you stencil it onto your board to when it needs to be reflowed.
That is, yeah.
And so often my boards, as you've seen, are quite. I don't know if I'd say complicated, but often they do have a lot of parts on them, like per board. I'll think I'll be able to get something done in time, and then it'll be like 2 a.m. and I'm like, I just can't place these components anymore. I got to go to sleep. And so I'll just put a cover over the board, like throw the board in just something so that dust doesn't settle on it, and just finish placing components in the morning.
Okay. Yeah, it's good too. I mean, you save. I mean, at a certain point, you literally have like diminishing returns. Your hands get shaky, your eyes get tired, everything like that, and you're just going to start making mistakes at that point. So
yeah, that's definitely learned that from experience.
I know this is going to sound weird asking this on an electronics podcast, but do you ever get sick of electronics?
I mean, there's definitely times when I'm less motivated to work on projects. I think everybody gets this, but there's just so many other facets.
It seems like you do a lot. I feel like I should say I am very much in awe of the work you do. Like, I think you do great work, Greg. And I've learned a lot from watching your Twitter feed and stuff like this, but it seems like you just do a lot. And then you do it at work too. So like that's awesome. But damn, that's why I was wondering if you get tired of it,
Yeah, no, I think there's definitely different facets that scratch a different itch in my brain. So like designing boards and then actually manufacturing them, I feel like they're definitely 2 different tasks. And I know other engineers that really love designing boards and they design fantastic boards, but like they would never even think about assembling them themselves. Yeah. Like they would just pay for somebody to assemble them. Either that's that they're just not interested in doing that, or that they don't feel like they have the skills, or it's not worth their time. I mean, so I feel like they are 2 different tasks, and I just enjoy both of them. The designing, definitely sometimes I definitely have days where, I've just, it definitely like it doesn't flow as easily. It's almost like writer's block.
Yeah.
It's like I know I have to place these, schematic blocks. I need a power management, section for this board, and
another buck converter.
Yeah. So like, I know what I need to do, but then like I get distracted and spend the afternoon watching YouTube videos or something.
I've never done that. I've definitely never done that every day.
And so, yeah, I mean, there's, like I said, there's kind of 2 different things. So sometimes I might get sick of, or not sick of, but like not designing like.
Yeah, you view them as all different tasks and different
the creative energy to like work on a new design. So I just pull off a box from my shelf and start writing some firmware for a project that I haven't looked at, and kind of try to doing something productive with my time, even if it's not the highest priority on the list.
I mean, as a casual observer, I want you to just do the cool things personally. So whatever you're doing, great with me, man. Honestly, I was just curious because it seems like you're very driven. So it's great. It's really great. What else do people know about you? I mean, we're kind of coming to our end here. So
yeah, well, I'm now realizing that at the start when I introduced myself saying that I'm from Twitter. I don't actually work for Twitter. I just post on Twitter.
Right. People are like sitting here this whole time like, man, this guy does a lot of electronics. I've never seen any Twitter products out there.
Yeah. No, I don't know. I have a blog as well, but I don't really post on there as often as I should, which I think is a common thread with blogs.
Should. Who knows should, It's just... You just haven't done it in a while. I haven't done it in a while, Blogs are so last decade. Really even the decade before that.
Yeah.
Cool. Well, that's good. Where can people find you? I mean, I guess Twitter is one thing.
Yeah, that's probably where I'm most active. Just onto my Twitter feed. I'm sure you'll have all this linked in the description of the podcast.
Yep.
Yeah, otherwise on my website, I think there's probably an email link at the bottom of my website. If anybody wants to reach out.
Cool. Well, Greg, thank you for being my Aussie stand-in this week. I mean, Dave's on holiday, and good to talk to someone from down under. It feels like a normal week, and I enjoyed talking to you.
Yeah, thanks. It's been fun talking to you too, Chris. It's a good start to 2020.
Yeah, definitely. All right, well, I'm sure I'll see you at a future conference because you seem to be traveling a lot, and I look forward to hanging out again.
Yeah, thanks.
See ya.
See you soon.